Every few years, a programming language emerges that doesn't just solve problems, it redefines how we think about them. In my 2 decades navigating IT infrastructure, from legacy monoliths to modern distributed ledgers, I've rarely seen a language generate the kind of quiet consensus that Rust has earned among engineers building systems where failure is not an option. Let me explain why I've come to view it as the backbone of the next generation of blockchain and high-performance computing. Memory safety. Without the performance tax for most of computing history, developers faced an uncomfortable trade-off. The raw speed of C/C++ came bundled with segmentation faults, buffer overflows, and memory leaks that caused an estimated 70% of security vulnerabilities in Microsoft's codebase, per their own 2019 analysis. Rust breaks that compromise entirely. Its ownership model and borrow checker enforce memory safety at compile time, eliminating entire categories of bugs before code ever runs, without a garbage collector slowing things down. In blockchain, where a single memory vulnerability can translate into millions of dollars drained from a smart contract, this guarantee isn't academic. It's existential. When I evaluate technology stacks my first question is always, what does failure cost here? For financial infrastructure, the answer justifies Rust's steeper learning curve many times over. The Stellar and Soroban case study. The clearest validation of my thesis lives in the Stellar ecosystem. Soroban, Stellar's smart contract platform, is built on Rust, and that choice was deliberate. Contracts compile to WebAssembly, WASM, inheriting Rust's safety guarantees while achieving near-native execution speeds. This matters enormously for tokenization projects, where deterministic, predictable execution is a legal and operational necessity. I've worked on tokenization pipelines where a Rust-based Soroban contract processed asset transfers with sub-second finality and negligible resource overhead. Compare that to older Solidity-based systems on congested EVM chains, where gas costs and reentrancy exploits, the DAO hack of 2016 cost $60 million, remain persistent threats. Rust's design philosophy, make invalid states unrepresentable, maps perfectly onto the requirements of financial-grade smart contracts. Polkadot, Solana, and Near also chose Rust for their core protocols. That's not coincidence, it's convergence. When the most demanding systems in Web3 independently reach for the same tool, the pattern speaks louder than any benchmark.